Hello, my name is Vikas Bhardwaj. In this video, I will walk through my project where I fine-tune a language model to predict likely diseases from symptom description and suggest precautions. Basically, this project is purely educational and all outputs include a safety note that this is not medical. So, before recording this part, I will show you the basically the type of uh, type of CSV file we have. We have disease, precaution 1, precaution 2, precaution 3, precaution 4. So this is all. And the disease and symptoms. .csv file. Disease, symptom 1, symptom 2, symptom 3, symptom 4. And that's all. So basically, the original data, original data set consists of diseases, their associate symptoms, and corresponding precautions. I firstly convert uh, I firstly convert the data into an instruction format using JSON files. Here you can see training training JSON uh, train.json file with 4,422 entries and test.json file JSON with 492 entries. Each entry contains three fields and instruction which tell the model to identify the disease and give precautions and input, which is the list of symptoms, and an output, which includes the disease name, a short explanation, the precautions, and the medical safety description. For example, in this entry, the input, uh, let's take an example. Uh, hmm. In this, in this entry, the input of list of symptoms and the output clearly specify the precautions. Here is the precaution, followed by the note that this is not medical advice. Basically, this project is for educational purposes, not for the advice you can give to anyone. Uh, now, now, once the data set was prepared, and I fine-tuned a GPT-2 model using LoRA, which is parameter efficient fine-tuning technique. I trained on Tesla T4 GPU for 2 epoch using a context language of 256 tokens and a cleaning rate of 2 times 10 to the power minus 4 basically. Here you can see the training loops. Uh, uh, here you can see the training loop, training loss decreases steadily over time, and it reaches the a value of around 0.42 by the end of the second epoch. 0.42 by the uh, basically end of the second epoch. This indicates that the model has learned to fit the task specific data reasonable value without overfitting too quickly. The log uh, in these logs uh, prints the loss every 100 steps, and we can see the loss going down from above to below 1, and then continue to improve into the range of 0.4. 0.4. Now we talk about the confusing matrix. Basically, this is the first output we get. I get basically. I get. I mean, in this we have so many, uh, so many. Cap. Sorry. so many labels that's so around it's around 200 something labels. So because of that, the label things are getting messy. So I again try with the new code that create the specifically confusing matrix. In this, it first show only first 30, then we can create basically confusing matrix is nothing to show that the things and the what we have done in the model. So after training, I evaluate the model on the test set and generate the confusing matrix. Each row represents the true disease and each column represents the predicted disease. Each row and each column. Darkest, darkest digital cell include darkest digital cell indicates that the model is correctly predicting the disease or those symptoms patterns. Off diagonal entity shows where the model is confusing similar disease, which is expecting in an educational budget like this. Uh, Now we have to run the we just run that model and get the output, which you see fever, headache, pain, body pain. So now we running this model. So these are the examples we are working on. This model generates a disease prediction and explanation and a list of precautions. It typically recognizes this pattern as fever related to the virtual like illness and suggests common precautions such as rest, hydration, medical consultations if symptoms persist. At the end, you can see the safety disclaimer. Uh, this is not medical advice. Consult a qualified medical professional for diagnosis and treatment. This is what I add specially because this is nothing. It's just a educational project. In second, I will show you itching, skin rashes, nodal skin eruptions. So in this, while we run for the second example, the symptoms are itching, skin rash, nodal skin eruptions. These symptoms usually correspond to a skin-related disease in the darkest, such as fungal infection or similar dermatological condition. This model again predicted disease level, explain that these symptoms frequently match the pattern to the training data, and list precautions. Here, here are the explanation and the precaution. So, itching, skin rash, these are the disease psoriasis. Psoriasis. Really, I have no idea about the disease. Keeping this affected area clean, avoiding irritations. These are the basically explanations and precautions. So in the third demo, chills, vomit, heavy fever, sweating. So now we run this project. I'm using the symptoms, what you see. These symptoms often appear in the dataset for diseases like malaria type, dengue. Here is the disease dengue. So basically, these symptoms often appear in the dataset for disease like malaria type or dengue type illness or other serious infection. These model generally generates a likely diseases category along with the recommended precautions, such as consulting the nearest hospital, avoiding certain food, and keeping the environment free of mosquitoes and other risk factors. These I will show the things what I got after the output of the model. So this is the LoRA GPT uh, to output. So this is the basically model what we train for the particular data set. This is the confusing matrix clean.png. Uh, this is same when which I create in the local machine. Simple output. So JSON what we talk about earlier, and this is the train.jsonl. So fine, here is the project structure. This uh, this is my repo, my GitHub account. I already uploaded here all the things. Simple output, test and changes. So this repo contains the Colab notebooks, the train.json and test.json file, confusing metric image, a simple output file with example generated, and the folder with the LoRA adapted and tokenized. This original Kaggle dataset and the full-based model weights are not included in order to keep the summation line true and within policy. If you want, uh, if you guys want, uh, we can do many more things in this project. We can make this project more in the vast data set, in the real data set to predict real diseases and real world for real world. So all this is the project. Now I summarize. I have fine-tuned a GPT-2 based language model using LoRA to map symptoms to likely diseases and precautions, and evaluated it with the confusing metrics and multiple example queries. This project is only for learning purpose, and all outputs are clearly labeled as non-medical advice. The code, data snippets, and the artifacts are available in my public GitHub repo, and this video link is also published as required. That's all. Thanks for watching.